Okay, so here's your review for your test tomorrow on Unit 3A, Graphs and their Functions. What you're going to see will be functions from Chapter 3, Section 4 and Section 5. You'll want to focus on looking at the graph to the right and checking to see which of these you could draw a vertical line through and only have it cross at one point. If it crosses at more than one point, like you see here, that is not a function. It can only cross at one point. Also, you'll want to be able to look at a table of data points and know which is a function and which is not a function. Remember, functions are ones where each x only goes to one y. It's not a function if you have an x going to two different y's. So this would make this not a function. Linear versus nonlinear. You need to be able to recognize, looking at your equations, what would make the graph linear or a line versus nonlinear when you would have a parabola or that squiggly shape. So exponents help make it nonlinear. So if you see a little 2 exponent or a 3 exponent, that means it will not be linear. The next thing you need to be able to do for your test is find the equation of the line from a given graph. So if you find yourself at this point on the test, look at the graph, find good points on the graph where it's intersecting on the grid's corners, and count up and count over between points. You can see with this one, we counted up 2 and over 2 to give us a slope of 2 over 2, which we simplified down to just a 1. You would also be able to find the y-intercept by looking and seeing where it crosses the y-axis point. The next thing you need to be able to do on your test is be able to find the slope, the y-intercept, and to write an equation. I would structure out your answer like the red text is here at right. I've got the answers in black. So red would be what you would want to set yourself up to be able to fill in to have the correct answer. And you'll be given a graph like you see here. And again, locate good points on your graph where it's crossing at the corners of the grid. Count up and count over. In this case, we counted up 2 and over 1 to have a slope of 2 over 1. Which we identified as our slope 2 over 1, and then we plugged in the spot for slope in our equation. And then we just need to find where it crosses the y-intercept to label as our y-intercept that we need to identify, and then to plug that in for our y-intercept for the finished equation of y equals 2x plus 3. The next thing you're expected to do on your test at least 4 times is find slope with a given set of ordered pairs. So if I give you the ordered pairs 2 and -3 and 5 and 0, you'll want to subtract your y's, -3 minus 0, and subtract your x's, 2 minus 5. Remember, it's always y's over top of x's, and then simplify that down from -3, -3 to your slope of 1. You'll see that 4 different ways on your test. And again, remember the difference with where the 0 is located. In this case, we subtracted our y's. 2 minus 2 left us with a 0, and you should know automatically at the top with the 0, you're given a 0 slope. But if 0 would have been on the bottom instead, if we would have had 0 here, that slope should be labeled undefined. The next thing for you to do is to find a y-intercept from a given equation that is not with y by itself. In order to find a y-intercept, you want to have y completely by itself before you start identifying the parts that are slope and y-intercept. So in this case, we have the equation -3 plus 6y equals 9. To get this y by itself, we have to move everything away to the other side of the equal sign. So I've added my 3x to both sides to get that canceled out. And I bring down my 3x, I bring down my 9, and I bring down the 6y. And then the math part of this will be finishing off with dividing by 6 at each point to get y entirely by itself. That leaves me with y, and then I'll simplify each fraction. 3 over 6 becomes a half. 9 over 6 becomes 3 over 2, and that means my y-intercept will be 3 over 2 because y-intercept is always the one that's by itself, not in front of the x. Remember to be able to explain which type of slope or ramp would be the better one for you to push a wheelchair or a heavy object up. This slope, in black, is an up 1 over 1, so a slope of 1. This slope in red is up 3 over 1. Pretty steep. For every 3 I go up, I'm only going over 1. So you can see I'm actually only dealing with a ramp that's probably about 3 units long as I climb up. Finally, I have my slope of 1 over 3 here in green, where I'm actually going up 1 but over 3, which makes a much easier slope, requiring less force for me to push up my object. Next on your test, you're going to write an equation where I give you the slope and one ordered pair. And from this being given to you on the test, you're going to write your equation in y equals mx plus b form. So, plug in the slope I give you right here in place of m. Plug in your x term in place of x. Plug in your y term in place of y, and solve for letter b, which again stands for your y-intercept. 1 times 2 gives me a 2. Subtract that 2 to get b completely by itself, and take that 2 over with that subtraction. 3 minus 2 leaves me with 1, so b would stand for 1. And to have my final answer, to get full credit, you would then need to write it in equation form with the slope you were given and the y-intercept you found in the correct location. Next, you're going to write an equation where I give you intercepts but no slope. Sorry, not intercepts. I give you coordinates, no slope. So you're going to have to find your slope first. Remember, to find slope, we subtract our y's, then we subtract our x's, and simplify it down to get a slope of 3, and then plug that in right there in front of the x. After that, with that slope plugged in, I want to plug in one of my sets of ordered pairs into each of the places for x and y. So in this case, I use the first one, 2, 3. I plugged in 2 for x, 3 for y, solved for letter b to find my y-intercept just like I had done on the previous screen, and then plug that y-intercept in place of b to get your final answer, and full credit with the equation of y equals 3x plus the negative 3, or you could just write minus the 3. Finally, you're going to want to write an equation and graph if I give you just a table. Remember, a table is a set of data that will give you points on your graph or points on your line, so pick any two. When we did this in the unit, we picked the 2 smallest numbers because it's easier to work with. You don't have to work with as big of numbers. And find your slope. Subtract your y's, subtract your x's, simplify it down to get the slope of 2, and that's where this 2 comes from in my equation, to write that equation. Then I'm going to continue with the slope plugged in and pick one of these sets of ordered pairs to plug in the x and plug in the y, to then solve and simplify down for the missing letter b, and in this case we got 0, and that 0 goes back in place of b in the equation to have the equation y equals 2x plus 0. Finally, you'll want a graph, and I'm just going to use our previous equation, considering you might get a different equation, but you'll still use the same method. Create yourself a table of data points, plug in 0, 1, and 2 into the equation. So 0 times 2 is 0 plus 0 spits out 0. plug in 1. 2 times 1 is 2, plus 0 gives me a 2. And then 2 plugged in, 2 times 2 is 4, plus 0 is 4. And now I have 3 sets of data points that I can graph: up 0 over 0, up 1 over 2, up 2 over 4, and connect my points.